Hi, I'm Kerry Mullen and I'd like to showcase some of the features of our latest application, TCR Explore. It's used for both the quality control and analysis of T-cell receptor repertoire data for both alpha, beta and gamma delta, and also incorporates flow cytometry data with our separate paired TCR data with index data. This is mostly based on Sanger sequence here, so I'll take you through that quality control process now. So the first step is to actually upload our seq files so they can be converted to the right FASTA format. So we'll just navigate here. Go back to the desktop. Go to the test data, quality control, second individual, microborn data. So all we're going to do is select all our .seq files. You notice that there are 96 files that have been uploaded. And one of the other things that need to be added during this process is to make sure the individual, group, chain, and initial well are part of the naming convention. For this particular data set, we were missing the individual, which is called T0016, T0016, 1 to 50. Just download that particular file and then we'll do the next lot of 50 files. As you can see, they get updated over here. Change that to 51 and this to 100, so everything's nice and labeled. So the next step is to go into our vquest. I'm going to use those sequences that we just downloaded. For this case, it's human and TCR repertoire data. Down here, I'm going to select XL because that's what we want to download, and the summary and the junction file. So here we're going to select our fasta files, which will be located in the downloads folder. So we'll just do these one at a time. So we'll download this file first, and then we're going to select the next slot once this gets downloaded to the next slot of sequences. So once that's downloaded, we'll go back to TCR Explore. The next bit we'll go to is our IMGT for the Sanger sequencing. Go to our own data and upload those vquest files. Just download all the required columns because we've got the summary and junction that's listed here. But if you just had the summary sheet, you can get most of the data you need out of that file. Right, so we'll download the second one and we'll go take a look at what's happened with these files. So over here you can see that there's a couple of columns that we've added to the end. One is the V sequence column here, that's based on the junction region. It's also based on the J region and the variable region. The diversity region is omitted because it's not in every type of sequence. And also if there's any flags to say that it was either productive or unproductive, and those sorts of errors come up. What we found that is those with no issues flagged by IMGT have good quality passes, so they got an automated pass. So what we'll do at this stage is I'll open up that second file. Should say number, it's the first one. We'll open up the second one, and we'll just copy and paste all of these down behind the other file, like so. I'd like to order these particular sequences in order. So what we want to do is just go through the ABCA1 files and see if these are any problems. So we'll just look at the CD8A for now. So own data, browse, let's go back to the desktop, this quality control, come on, and we'll have a look at this particular file. So what we can see here is this is actually a fairly good quality chromatogram, and it's coming up as unproductive. However, it would be good to have another look at this in more depth on also IMGT. But based on this cleanliness of the sequence, it's got a fairly good clean sequence, so there could just be some stop and start codons right here, which is the only issue that's been flagged. Rightio. That pretty much gets us through that. So what we want to do is copy and paste all those individuals into the one file, which will end up resulting in our final data set. So we've already pre-filled this in as passes and fails and the reason for the failure, or whether or not we could manually resolve the issues, or if it wasn't actually a real issue to start with. So go back to IMG sequencing, go back to the paired. I'm going to upload that file, which is already in the background data set, so which is in the test data. We've got a summary of what passed, what failed, on how many, and then we get to our final paired file, which also adds some nice sequence information at the end to help with the generation of the figures. You can also download the equivalent TCR dist if needed, because it matches all the column headers necessary for that. So just as an example, just open this up when it's ready. And this is what it looks like. So we've got all those sequences. The well ID gives it a unique identifier, and that's good to go for TCR dist 2. So there's also been an instance if you just had one singular chain as opposed to doing paired chain alignment. Again, that there is the opportunity to just extract the necessary information based on those passes and failures and add those nice columns to the end as well. So once that's downloaded, you'll be ready to perform either the TCR analysis section or continue with an additional quality control process if you had paired fax index data.